Welcome to today's class. Today I am going to explain a very important topic, that is monotonicity of a function. So here a function means a curve. Curves have different types of natures. Some are increasing, some are decreasing, some are both increasing and decreasing. Some functions neither increasing nor decreasing. Okay, all this we discuss in the topic monotonicity of a function. What is the maximum value it will take? What is the minimum value a function will take? All this will be discussed in this chapter. It's a very important topic for your JEE mains examination, also for your board examinations. Okay. Coming to our chapter, monotonicity. Mono means same. Mono means same. Tono means side, same side. That means it should follow the same property throughout the given domain. Okay, now, for example, this topic discuss the turning of the curves. Turning of the curves. Okay. How the curves turn, in which domains it takes a maximum and a minimum, in which domains it takes a minimum and a maximum, all this will be discussed in this chapter, monotonic function. See here, there are certain functions which are always increasing. For example, y is equal to e power x curve is there. Y is equal to e power x curve is always an increasing, it is an increasing function. Okay, now, if you take y is equal to log x to the base 1 by 2, it is always a decreasing curve. It is a decreasing curve. Such type of behavior, that means either it should increase or it should decrease. Such type of functions are called monotonic functions. Monotonic functions. That means they should be either, already we explained about the increasing function and the decreasing functions. Okay, either it should be increasing or it should be decreasing in the entire domain. In the entire domain of the given the function, the entire domain of the given function. Such type of functions are called monotonic function. Either it should increase or decrease. Sir, what about non-monotonic functions? The best example is y is equal to sin x curve. See the y is equal to sin x curve, always we see that it is in the domain, it is behaving both characters. It is increasing and decreasing, increasing, decreasing, increasing, decreasing. Therefore, y is equal to sin x is called non-monotonic function. Non-monotonic function. Another best example is y is equal to x square. Y is equal to x square. What is the graph of y is equal to x square? Everybody know. We know that it is a parabola. That means that curve have both natures. That means it is increasing, again decreasing. That's why this is also non-monotonic. Non-monotonic. So, on the whole, if we conclude that this monotonic function, we will discuss about the turning of the curves. Okay, now turning of the curves. It is should be either strictly increasing or should be decreasing. Any one character should have, then only we will call it as a monotonic function, either increasing or decreasing. If it showing both type of characteristics, that is increasing and decreasing, increasing and decreasing, if that type of characteristic is showing in the domain, that means what is the domain of sin x? X is a real numbers. X is a real number. That means the set of real numbers, the function is both increasing and decreasing, increasing and decreasing. That's why sin x is not a monotonic function. Here also y is equal to x square is also, it is behaving both type of characteristics, that is increasing and decreasing. That's why that is also not a monotonic function. Okay. Now we are going to see the monotonic nature of the function at a point at a interval. Okay na? So let us see that. Now our topic is monotonicity at a point. That means given a function at a point, how to check whether it is have monotonic nature or not. Okay, let us see that. First of all, let us take a function y is equal to f of x is an increasing function. It is an increasing function. That means x-axis and y-axis, it is an increasing function. Okay, it is an increasing function, right? I want to check the monotonicity at a point x is equal to a. At a point x is equal to a. I want to check here whether it has a monotonic behavior or not. Okay. In the neighborhood of this, let us take another points x is equal to a plus h. Here x is equal to a minus h. Here, see here, h is a very small minute variable, that is this point just lies beside of this x is equal to a. So this is equal to and this is equal to. Okay. So here clearly a minus h is less than a plus h. A minus h is less than a plus is, for h is a very small quantity. Observe their images. Observe their images here. What do you observe here? So this is a minus h f of s. This is f of a. This is f of a plus h. That means f of a plus h. That means f of a minus h is less than f of a minus h is less than f of a is less than f of a plus h. F of a plus h. Understand this? That means if this is this property satisfies, if this property is satisfies, we say that the function has monotonic nature, and moreover it is increasing at the point x is equal to a. The function is increasing at the point x is equal to a. Okay, now let us see the same topic for decreasing function. Let us take y is equal to f of x, a decreasing function. Let us say a decreasing function. Okay, let us check this. And this is x-axis and y-axis. This is a decreasing function. Everybody knows that. Let us check the decreasing nature at x is equal to a. At x is equal to a. In the neighborhood of a, let us take any 2 points. So this is equal to x is equal to a plus h, and this is x is equal to a minus h. A minus h. Okay, now observe their functional values. So this is equal to f of a minus h, and this is f of a, and this is f of a plus h. F of a plus h. Okay, now that means a minus h less than a plus h. A minus h less than a plus h. If you observe here, f of a minus h is greater than f of a is greater than f of a plus h. A minus h is greater than f of a is greater than f of a plus h. Understand this? Okay. That means to check the monotonicity at a point, so at x is equal to a, so this property, either this property should be satisfied. Then only we say that the function is monotonic at the point x is equal to a. That means either it should increasing or it should be decreasing function. At a point a, both should be satisfied. So this type of conceptual knowledge is very important for your JEE mains or advanced knowledge, JEE mains or advanced problems. There are certain problems that you have to use these properties. These properties you have to use. Okay, now Now what we are going to see, the monotonicity of a function in an interval, that means here we are checking this monotonicity at x is equal to a, we are checked here, x is equal to a, we checked. Now we are going to check the monotonicity of this function in an interval, either it has a turning nature or not, either increasing or decreasing. We are going to check in an interval. So now what we are going to check is, given a function using this is a, just now what we explained is, it is a method of checking the given function is have a monotonic behavior or not, that means either increasing or decreasing in the given interval. Okay. Without that, in another way also can we say that using the derivative concept. Okay, na? So let us see that. See here, I am taking here one function. So that is an increasing function. So this is x is equal to a and it is x is equal to b. Understand? See here, this is f of, call it as otherwise you call it as x1 and it is x2. Okay, x1, x2. So this is f of x1, this is f of x2, that is equal to, this is y1 and this is y2. See here, already we say that the difference of this here, how much here? Delta x. That means here x1 and x2 minus x1 is the difference will be delta x. Let us denote it with the delta x. Here the difference is also denoted with the delta y. Okay, now if you observe here, delta x is greater than 0 and delta y is also greater than 0. Okay, f of x1 and it is f of x2. For increasing function, the difference of these two quantities also positive. Delta x by delta y is greater than 0. That means delta y by delta x is greater than 0. Delta y by delta x is greater than 0. For very, very small values, for very, very small changes, very small. That means what? If these 2 points, that is x1 and x2, if they are very come closer, that means they are like this only, just side by side. X1 is there. If you go on decreasing this, the difference, if you go on decreasing, so this delta y by delta x will become dy by dx. Delta y by delta x becomes dy by, for small changes. Okay, the rate of change of the y coordinates with respect to x coordinates. Okay, now that means here whatever may be this change delta y, that depends upon delta x, right or wrong? That means as you move this interval, that means x1 and x2 values, as you move, according to that your y values, delta y value also will change. As you move close, if you close x1 and x2 points, so they are very, very close to a certain limit. Here delta y also very, very close. Understand? So the change in f of x and f of x2 depends upon the change in the interval, in the length of the interval x1 and x2. That means the rate of change of y, with respect to x, that is dy by dx, the very, very small changes. Okay, now this is greater than 0. Now dy by dx is nothing but f dash of x greater than 0. Notation, dy by dx is nothing but f dash of x greater than 0. That means f dash of x means what? Again I explained that it is the slope of the tangent at a point. If you take x is equal to a, in general x is equal to a or x is equal to x, the slope of the tangent, so this is the slope of the tangent, it should be greater than 0. That means if you take theta, tan theta is greater than 0, positive. Why? Because for an increasing functions, if you draw a tangent, it always makes acute angle with the positive direction of x-axis. Acute angle, wherever you draw, you can draw wherever. So if you from here, you draw this here, acute angle. You can draw this here, again here, acute angle. For an increasing function, wherever the point you take, if you draw a tangent at that point, it always makes acute angle with the positive x-axis. Acute angle means what? 0 to 90, first quadrant. First quadrant means what? Tan theta is positive. Tan theta means what? Nothing but slope of the tangent f dash of x is greater than 0. So here onwards, we conclude that for an increasing function, f dash of x, if you are able to show that f dash of x is greater than 0, then it is an increasing function, so that it has a monotonic nature. Monotonic nature means it is strictly increasing. Okay, now let us see what happens if it is a decreasing function. Let us see that. So this is x-axis and the y-axis. Okay, right. So let us see this decreasing function. Okay, right. So here is saying here, so this is a x is equal to x2 and this is x is equal to x1. So this is equal to f of x1 and it is f of x2. Okay, now the change in the, that means as you close to this interval, those two upper bound and lower bounds, if you close that, this change in these intervals is delta x, this is delta y. So if you observe for a decreasing function, if delta x is greater than 0, the change in the rate of change of x, the rate of change of delta y with respect to x will be negative. That means here, see here, this is f of x1, it is f of x2. F of x1, this is f of x2. For example, see here, x1 is less than x2, but f of x1 is greater than f of x2. F of x1 is greater than f of x2. That means x1 minus x2 is less than 0. F of x1 minus f of x2 is greater than 0. That means if the change in x is negative, the change in the y coordinates is positive. For suppose if it is positive, that will be negative. Try to understand this. If it is positive, it will become negative. That means if you take x2 minus x1, it is greater than 0, then f of x2 minus f of x1 will be less than 0. Understand this. That means if delta x change in x coordinates, the rate of change of the x coordinates is delta x is greater than 0, then delta y is less than 0. Delta y is less than 0. That means delta y by delta x is less than 0. That means the rate of change of the length of this interval here, it depends upon the rate of change of there on the x-axis. Okay, now right. Delta y by delta x, same argument for a very, very small changes. That means if you take this x1 and x2 just side by side, there will be a very, very small variation will be there. According to their delta y is also a small variation will be there. This is equal to dy by dx is less than 0. Dy by dx is less than 0. Dy by dx is nothing but f dash of x. F dash of x is less than 0. Already we know in our discussion differentiability, we have explained that f dash of x is less than 0. What is the meaning of this? F dash of x less than f dash of x means what? Slope of the tangent at x is equal to a, or if you take f of a, slope of the tangent at x is equal to a, that is saying less than 0. Saying the slope is negative. Why? See here theoretically. See here, you take any point on the interval x1 comma x2. If you draw the tangent, see here, this is theta. That is obtuse angle you will get. So any tangent you can draw, any tangent, more than 90, theta is greater than 90 degrees, obtuse angle. Obtuse angle means what? Second quadrant, more than 90, second quadrant. Second quadrant tan theta is less than 0. Tan theta means slope of the tangent. Slope of the tangent. Slope of the tangent is nothing but f dash of x. F dash of x is less than 0. Understand this? So, for an increasing function, f dash of x is greater than 0. For a decreasing function, f dash of x is less than 0. So, to check the monotonicity of a function in an interval, to check the monotonicity of a function in an interval, it is enough to check the value of f dash of x. If this f dash of x is greater than 0 for all x belongs to domain of that function, for all x belongs to domain of that function, we say that the function is first of all monotonic, and we call it as monotonically increasing function. Okay, now, if it is f dash of x is less than 0, if f dash of x is less than 0, then we say that the function is monotonically decreasing function, monotonically decreasing function for all x belongs to domain of that entire function. Understand this? Okay, right. I hope that. So, first before I explain using that interval concept, only taking the points, here I explain that using the derivatives, how to check the monotonicity of a function. Monotonicity means what? The function should be either increasing or decreasing. It should not have dual nature. Dual nature means what? Both increasing and decreasing, just like sine function, cos function, tan function. Tan functions also, tan we can say monotonically increasing only. Okay, right. All tan functions are monotonic behavior. Sine, cos, cosecant, secant, all these they are non-monotonic function. All quadratic expressions also non-monotonic. Okay, na? So, let us see one more concept. I am going to explain a very important definition, two definitions. One is stationary points and critical points. Generally, students will get confusion with this stationary points and critical points. Okay, so I will explain very clearly. For example, take any non-monotonic function. Non-monotonic function. Non-monotonic function means what? It has both increasing, decreasing nature. Okay, now let us take that function. Like that, it is a non-monotonic function. It is in a given domain, it is neither increasing, it has both an increasing and decreasing nature. There are certain points there are certain points in which, for example, if x is equal to a, if you draw the tangent there, f dash of x is equal to 0, or f dash of a. If you take the point a, that is f dash of a is equal to 0. That means what? If you draw the tangent at the point here, the tangent is parallel to x-axis. Tangent is parallel to x-axis. What is the slope of the x-axis? 0. Therefore, the slope of the tangent is also 0. This point is called stationary point. This point is called stationary point. Understand? So, here one more stationary point is also there. See here stationary point. Stationary point. So, here if you draw the tangent here, x is equal to b, f dash of b is equal to 0. If it exists, if it is f dash of b is equal to 0, then we call it as a stationary point. Stationary point. There the tangent drawn at the point is parallel to x-axis. Those points are called stationary points. Okay. What about critical points? We will see that. So, what is the critical points means? F dash of, first of all, this should be exist. Here f dash of x should be exist. F dash of x should be exist. F dash of x is equal to 0 or f dash of x does not exist. Does not exist. For critical points, f dash of x is equal to 0 or f dash of x does not exist. f dash of x does not exist means here again 3 conditions will come. F dash of x does not exist means 3 conditions means what? It may be non-differentiable at the point x is equal to dash if it is a non-differentiable, or discontinuous at that point x is equal to a, discontinuous, or it will have a vertical tangent, then also f dash of x does not exist. Vertical tangent means slope, it is a parallel to y axis. Then also f dash of x does not exist. That means, for example, I will draw a diagram. For example, one function is there at x is equal to a and it is there. So if you observe here it is discontinuous. Okay, now at this point f dash of x does not exist. Does not exist. Therefore, we call it as a critical point. X is equal to a is a critical point. Okay. For suppose if our function is some sharp edge, it x is equal to a, sharp edge. At that sharp edge, function is not differentiable. Therefore, this point is called critical point. We call it as a critical point, not stationary point. This point is called critical point, not stationary point, whereas this point is called stationary point. From this we can say one thing. What is that? All stationary points are critical points. All stationary, that means what? F dash of x is equal to 0. The definition here also includes. All stationary points are critical points, but all critical points, see here, all critical points, here also x is equal to a. So there are certain functions are there. There you will get a vertical tangent here, x is equal to a, vertical tangent you will get. So these are all x is equal to a, x is equal to a, x is equal to a. They are all critical points. They are all critical points, but here they are all stationary points. That means you should have a sharp edge. If you draw a tangent, the tangent should be parallel to the y-axis. That is called stationary points. Here can you draw a tangent? So you cannot draw a tangent. You can draw an infinite number of tangents, which they may be parallel to x-axis or may be parallel to y-axis. We don't know. That's why all stationary points are critical points, but all critical points need not be stationary points. Okay. These stationary points sometimes are also called as turning points. They are also known as sometimes turning points. Why they are called turning points means, see here, up to here the function is increasing, again it is decreasing. Again it is decreasing, from it is increasing. From this point, from that stationary point only, the function is either increasing to decreasing and decreasing to increasing. Understand this? Okay, right. So where it is increasing and where it is decreasing, where it will have maximum and where it will have minimum, that we will see in the next class. Okay. I hope that you understand this today's class with some more topics and some more concept. Tomorrow's class I will stand before you. Until then, all the best.